Hi, everyone. My name is Nathan Rowe. I am an ecologist for the NRCS in the Sonora, California office. And I want to talk today about a ecosite reporting tool that I've put together um, that is essentially a way of summarizing ecological sites that assists with the process of populating edit primarily, but also serves as a quality control tool as well. Um, so uh, Many of you are probably familiar with EDIT. It's the ecological site database that's used in the NRCS. And there's lots of information that needs to be populated in EDIT for ecological sites. So there are sections on physiographic features and soil features and climate and water, all of that. And within each section, there are lots of different properties that need to be populated from different landforms, or flooding and ponding frequency, or elevation, slope, all that type of information. Um, the way that that information ends up being populated is essentially summarizing component data. So ecological sites are correlated to map unit components. So when we're summarizing the data associated with an ecological site, we're really kind of aggregating the different map unit components that are correlated to an ecological site, and then summarizing that data from those different components. So many of you have probably used different NASAS reports that basically produce lots of different ecologically relevant information about different components, such as slope and elevation and texture and soil depth and subsurface fragments and all those types of things. And it spits out kind of a HTML document, and you can put that into Excel and make pivot tables and things like that. And so the report that I have been putting together is really just a visual representation of that data, so that you don't need to produce pivot tables and things like that. And in a separate video, I show how to go through the workflow of actually building these reports, but it's very straightforward, and you end up creating reports. You'll have a folder such as this. You can see these are each one of these is has the name of a certain ecological site, and each one of those is a report that looks like the report that we have open here. And the process is automated so that once you initiate the process, it builds an ecosite report for all of the ecological sites, whether it's in an MLRA or whether it's in a soil survey area, depending on how you have defined it. And that happens you could run this for hundreds of ecological sites, depending, on how many ecological sites are in your soil survey or MLRA. And it takes about 30 seconds for each site to run. And you can just, once you get it going, you could walk away and just let it run itself, or you could do some other task and let it run in the background. So I'm not going to talk about how to build these reports. That'll be referenced in a separate video. But what I do want to go over is how this report works, so that all of you have an understanding of what happens in this report and how best to use it. So to start off, the report in the top will define which ecological site it's working off of. And just as a reminder, this is basically, it is just summarizing all of the components that are correlated to an ecological site, and it builds off of a NASAS report. So it's kind of a summarization of a NASAS report. So in the beginning of this report, it has a section titled Important Discussion. So we'll go over a few of those factors. The first one being that this report uses two things. It kind of summarizes data in two ways, based on the number of components as well as the component acreage. So if we scroll down here, we can see the first thing that it reports is based on landform. So this ecological site that we're looking at, let's figure out how many components it's correlated to. Well, we would add up all of these different numbers here. So 6 and 4 is 10, 11, 13, 15, 16. I think I counted that right. So there are 16 different components correlated to this ecological site. Those 16 different components had some different landforms that were used. The most common landform that was used was mountain slopes. 6 of the components were described as having a landform of mountain slopes. Whereas down here, moraines on glacial valley walls, there was only one component that was described that had a landform populated as moraines on glacial valley walls. You can also see which components. So you can see that this is the component ID, the component IID. So this is the component that was described as moraines on glacial valley walls that is correlated to this ecological site. And then you can also see the acreage. So in this instance, you're seeing that this one component had a total of 424 acres. When you have multiple components, you can't exactly tell how many acres, at least in this view. We will see later on that you can distinguish how many acres each component is associated with, but in total, these 6 components, which are defined here, summed to a total acreage of over 27,000 acres. So you can see here that we summarize the data both by acres and by the number of components. And we kind of consider the acreage to be most important in this report. And so this table, that you can't tell in this instance because they follow the same pattern, but it's actually sorted by acres. So if you had a situation where one landform had more acreage but less components, it would appear at the top of the list because it has more acres. So then this is also, those landforms are used to make a word cloud visual, which is used in a couple different places in this report. And that basically breaks up each of these words. So it would break up mountain from slopes. So mountain is treated separately and slopes is treated separately. And each of those would be associated with 27,415 acres. And then you see here, mountain appears again. And then this time it's with 8,163 acres. So that's increasing, more acres associated with this word mountains or mountain. So you end up producing a word cloud. And this gives you the overall feel of kind of the landform that this ecological site occurs, which mountain slopes and mountain slopes with moraines is coming through pretty clearly. This table here just gives, this is kind of the actual weighting of these words. So you can see here that mountain and slopes were used the same number of times. So that would suggest that neither mountain nor slopes were used in any landform without each other. There, every time you saw mountains, slopes were there too. So mountains and slopes occurred together. If just mountains were to have occurred in this landform and not slopes, then that would have increased mountains, so it would have appeared higher. And so this gives you the kind of more detailed breakdown of which terms were being used the most. And then it goes into flooding frequency and flooding and ponding frequency and duration. And this site does not have any flooding or ponding, so I'm going to kind of skim through this real quick. We'll go down to elevation. And so then you can kind of get a feel for elevation. Okay, so for elevation, we're seeing, again, data is being summarized by, on the left, the number of components, and on the right, by the number of acres. And you'll see that the distribution changes slightly. So when we look at things by just the number of components, each unit is of equal importance. You'll see the size of these bars is all the same. Whereas if we look at elevation, now all of a sudden the bars are of different sizes, and that's because each of these bars is weighted by the acreage of each component. Okay, and you can hover over these bars and identify the component ID as we did last time. So this component here is 2485178. So this is a fairly high acreage component. And you could come over here. So 2485178. You see that same component here, 2485178. And so the acreage of components kind of changes the way that we think about the distribution of the data. And this report considers acreage quite a bit. It uses acreage to calculate some standardized values that it proposes to be used to populate edit. So in edit, we are asked to populate a high actual, low actual, a high representative, and a low representative. And so this report will go through and propose values to enter for each of those different properties, the high actual, low actual, and so on. And in doing so, it uses an acreage weighted consideration of these components. So that's another factor where it's really important to consider the acreage of these different components. On that note, this report is also useful for identifying outliers, kind of as a quality control measure. So if this component here were of some concern to you, that it might be an outlier, that this is too low of an elevation and it should not be correlated to this ecological site, you can hover over it and identify the component ID. And that would allow you to query for that component and look at more properties of that component and determine whether it is an appropriate correlation. And what I want to stress is that it's very important for high acreage components to have a correct correlation. This component here we can see is of quite low acreage. And so that's not going to shift the distribution considerably. And when we're calculating these standardized values, it's not going to affect those calculations all that much. If this component here that's kind of bordering on outside of the range, if that's what an ecologist were to determine, if it were of a quite high acreage, if it were associated with 10,000 acres or 20,000 acres or something like that, like some of these others are, greater than 10,000 acres, then in that case, it really would have a considerable effect on the distribution of the data and the way that things are calculated. So you really want to look through and make sure that all the correlations make sense to you, and that particularly for high elevation components, that it looks like they are properly correlated, because that can have a significant effect. So that's kind of the discussion on looking at data by the number of components and the acreage and the number of acres. So now we'll get into discussing the standardized values that I mentioned. So you'll notice when we were looking at elevation that there is a value here that's proposed. Right here, it says elevation high acreage weighted 95th percentile. And it's saying use this as the high actual value. And then it proposes a value. It says the 95th percentile is 10,420. And then you would very likely want to round that value, maybe up to 10,500. But this is the value that it's proposing for the high actual. And so I want to explain how these values are calculated. And so to do that, I will bring up Excel here. Okay, so let's look at a few kind of a mock data set. So we have some components, and perhaps we're interested in their elevation, and we want to know their acreage, because the method for creating these standardized calculations of values relies on the acreage. So we might have component A, and then we have component B. Oh, we have component B and component C. Component A has an elevation of 100. Component B has an elevation of 300, and component C has an elevation of 500, let's say. and each one of them is associated with a different number of acres. Component A is associated with 2 acres. Component B is associated with 5 acres, and component C is associated with 3 acres. So we have 10 total acres. And the way that this report works is that it will use an acreage weighting. You'll see in lots of different places it references an acreage weighted percentile. So what does that mean? Acreage weighting just means that we will numerically sort these values. So we have 100, 300, and 500. Just so happened I gave them in the correct order, in kind of the numerical order that they appear. So component A is associated with 2 acres. So we'll repeat that value, the elevation of 100, twice. Component B is associated with 300 acres, and component B, has an elevation of 300, and is associated with 5 acres. So we'll repeat that 300 5 times. Okay, and then component C has an elevation of 500 and associated with 3 acres. So this is essentially the acreage weighting process. You're repeating the value based on the number of acres. Okay, so we have that there. Now there are a few different values that we want to populate and edit. There's an actual high, there's an actual low, and then there's a representative high and a representative low. And let's I'll move these over here. Okay, so how are these calculated? The actual high will use the component high data. Let's say it like this. It will take the 95 percentile of the component high data. Actual low will take the 5 percentile of the component low data. So let's look at that real quick. So one thing that we didn't mention yet is that there are elevation highs, or there are component high values and there are component low values. So let's introduce a new column. Sorry, we'll just move this and make a little more space. That column's a little wide, but we'll just be fine with that. So let's say this is the elevation low, and then we have an elevation high. And so the high values are going to be higher, presumably. So this might be 500, and this might be 700, and this might be 900. Okay, so for our actual high, we're going to take the 95 percentile of the component high data. So we would essentially do the same thing. We would take our component high data. So these are our elevation high values. We would acreage weight them, and then we would calculate the 95th percentile. Well, how do you calculate the 95th percentile? We have a total of 10 positions here, right? This is 2 plus 5 is 7, plus 3 is 10. So there's 10 total acres here. 10 total acres, so you're going to have 10 total values because of the acreage weighting. Now, if you take 10 total values and you multiply that by 0.95, you get a value of 9.5. So that's essentially rounding up to 10. That is the 10th position. So we do this all by position. So the 10th position would give us the last position, which in this would be 500. But actually, because we're working with high values right now, we would acreage weight these values, and the 10th position would end up being the 900 because, yeah, it would have our last three values would be 900, 900, 900. If we were to, and we'll just do this just for clarity. So for the high values, do the same thing. 500 twice, 700 3 or 5 times. Okay, that's 5 times. Okay, so these are our low values, and these are our high values. We'll call it low acreage weighting. And then high acreage weighting. So here are our values. So we did our 10 positions times 0.95. That gives us position 9.5, round up to 10, and position 10 is this 900. So our actual high would be the value 900. Our actual low is the 5 percentile of the component low data. So the low data are these data here. We would do the same thing. We would take 10 positions times 0.5. Oh, sorry, I must have done times 0.5. 10 positions times 0.05. 0.5 rounds up to 1, and the 1 position is always the lowest. So any value below 0.5 would also round up to 1. And that would give you this value 100. So then the acreage weighted low value, acreage rated 5 percentile for the low data gives you value of 100. So now we get into, we don't actually need to delete those. Now we get into our representative high and low values, and these are calculated a little bit different. So for our representative high, we do the 80 percentile of the combined component low and high data. And for a representative low, we do the 20 percentile of the combined component low and high data. Okay, so for this purpose, it says combined low and high data, right? So we would basically just take both of these. So we probably won't be able to get these all on the same screen, or maybe we will. So we combine the highs and lows, and they would still be in numerical order. So there's a chance that you could have some overlap. You know, if this value were 400, then that 400 would get moved over into the correct position after 300 and before 500. But it just so happens in this example, there's not any overlap between highs and lows, which is somewhat common. So now we have 20 positions here. 20 positions, and we want 20 positions. And now for the representative high, we want the 80 percentile. So 20 positions times 0.8 is 16. So we would take the 16th. So this would be 20, 19, 18, 17, 16. So the representative high value would be 700. And we would do the same thing. We have 20 positions times 0.2 for the 20 percentile. That's 4. 1, 2, 3, 4. So this would be a value of 300. So now you have a actual high value of 900, an actual low value of 100. So the actual range, you know, This site can range from 100 to 900, but more representative condition would be ranging from 300 to 700. So where did these values come from? The 95 percentile, 5 percentile, and the 80 and the 20. These values are described in edit. And so if you read here, it says in most cases, approximately 60% of the time, the ecological site is expected to occur within the range specified by representative. So 60% of the time. So that's why we have from 20 percentile to the 80 percentile. So we have the inner 60 percentile of our data. And then only in rare instances, approximately 10% of the time, is it expected to occur outside of the range specified by the actual values. And so that's where we go from the 5 percentile to the 95 percentile. And that gives you the inner 90 percentile with 5 percentile on each side. So 10% of the time, that value would be outside of the specified range. So that's where those values came from. Okay. So yeah, so we can see here that this report will, it will first look at our component high data. So here's our elevation high data, and it provides a an elevation high acreage weighted 95th percentile, uses the high actual. This is what we just looked at. And the 95 percentile is that 10,420, round up to 10,500. And then it gives the elevation high acreage weighted summary statistics. So this is still acreage weighted. So the values are replicated based on the number of acres. And then it just takes summary statistics, the min and the max, first quartile, median, mean, third quartile. And then the report goes on to look at the component low data, summarizes it visually, and then proposes an elevation low acreage weighted 5th percentile. It uses the low actual, which we also calculated. It's the 5 percentile of the component low data, and it provides value here, 5,630, maybe you round that to 5,500. And then also gives these acreage weighted summary statistics, and then it goes on to the representative, which is just the combined low and high. So these two distributions that you looked at previously, if you kind of memorize this shape right here, and then we scroll down, you see that that shape is right here on the right side of the screen. Sorry. So that's the low data. I thought it didn't match up that well. So if you memorize this low shape, you'll find that that low shape is right here. That looks more like it. So there's the low data. And then now we have that combined low and high. We're looking at all the low and high data visually, kind of looking at that summary. And then we calculate the 20 percentile and the 80 percentile, and we get about 7,000 and a little over 10,000. So, so those would be the values that this report is proposing to enter into edit. And so the hope is that you use this as a QC tool. If you identify something that looks like a bad correlation, you take care of that. And then hopefully if there aren't any bad correlations, these values, the way that they're calculated, are fairly well described by edit. This kind of follows the logical thought process described in edit to make these calculations. So hopefully they're appropriate for you in most cases. Of course, if you have expert knowledge that deviates from these values, you should certainly use that. And it might be worth considering why the values are not representative of what you expect. And you could potentially comment in edit. There's room for comments down at the bottom of each section. You could perhaps make a comment about why you think it might be different than, if it's considerably different than the data would suggest, maybe make a comment about that. So this report's going to go through all of the different properties that you need to populate in edit. I do want to show you how categorical data can also be used. And here's, as we're scanning through, I'm also reminded here that each section, the first time that you go through this report, it's really worth looking at each section because there are lots of comments that are included. So it says here, one thing to clarify about ponding depth, this is a measure of how deep the ponding is above the soil surface. If an ecosite does not have ponding depth, uncheck the box. And then you will see this occur depending on your ecological site where you don't have data and you don't have figures, and this report will spit back to you no data populated in NASAS for this field. In that case, as described here, you should uncheck the box associated with that field. So what does that look like? It would look like unchecking this box. So that would suggest there's no flooding. Flooding might be a bad flooding frequency might be a bad example of that because you can select that there is no flooding frequency. But if there was just no data populated for that field, then maybe rather than saying there's no flooding frequency, you might actually unselect it. Or, it's probably quite unlikely that for slope or elevation they're missing, but if that were somehow to have happened, you would just choose to not report slope if you had no data regarding that field. Okay, so now we'll get down to these categorical variables. Let's look at drainage class. I'll just jump down to one of these. Okay, so here's drainage class. So we see drainage class here of well and somewhat excessively. And you'll notice that values are still populated. They're still recommended values for the low actual and the high actual and the representative high and low. And so I just want to clarify how those are calculated. So for these types of categorical variables, I'll go back. For these types of categorical variables, they're actually considered ordinal. So they're not numeric, but there is an order to them. You could have poorly, and you would acreage weight them, right? So maybe this is associated with 2 acres, and then you might have somewhat poorly. And maybe somewhat poorly is associated with, and then maybe you have well. There's just 1 acreage of well, 1 acre of well. So you can acreage weight these, and you can also order them, right? From poorly to somewhat poorly to well, or moderately well. And because there's an acreage weighting, there's a number of positions and there's an order, you can still do the same thing. You can still calculate a position. So you can still do that, if there's 5 positions and we want the 95 percentile, then we'll take the 4.75, round it up to 5. So we would have well drained. And these things are, a lot of times the rounding is not nearly as significant because these things are associated with hundreds or thousands or tens of thousands or more acres. So these small examples make the rounding seem like they have a big influence, but with the types of weighting that we see in real examples, it's much less significant. But so this is how, for our categorical variables, we can still calculate proposed values using that acreage weighting, acreage weighted percentile technique still. Let's come back up to the top and see. So I think that really covers this standardization section. So that's how standardized properties are calculated. There's some other reminders in here. Edit at this point does not accept non-numeric values like NA. So I mentioned previously that, if slope wasn't populated, to uncheck the box. And that's something that you need to do rather than put an NA in. This is just kind of a brief reminder. It's not particularly related to the report, but if you put anything non-numeric in these fields in edit, if you put a slope of NA and and really a more likely scenario where you might want to do something like this is if you have some sort of depth, maybe a depth to restriction, right? And maybe your depth really goes up quite high in some situation, right? So the representative range is from 39 to 40, and these would probably want to be rounded to 40, but I won't do that. So representative is kind of from 39 to 60, and then the low might be from 39, but then it goes very deep. And in some situations, there's no observed restriction, and you might want to put NA. Well, if you do that, this value will be changed to a 0. So that's something where you have to decide, and that's probably what happened here, where we see 60. That's kind of a common max depth value that's used. And so if you want to report a depth, if there's no restriction, then you might just unselect this. That would suggest there's no restriction observed. But if you have low restrictions, and you have kind of that span where like there is a restriction at the low, but at the high, there's no restriction. It's not observed. The edit's not currently really capable of dealing with that. I can't have those non-numeric values like NA. Okay. This report, as is probably clear at this point, it relies on acreage quite a bit. And some folks, maybe for initial soil survey and things like that, there's not acreage currently reported for components. In that situation, this report will state which components have a missing acreage, where it's just there's nothing populated, or if there was a component that for some reason had an acreage of 0, that component would be listed here as well. And there could be a situation where you're doing initial soil survey and you want to use this report to kind of see if the range of things that you've correlated to an ecological site is reasonable, and you don't have some massive span of elevation or something like that, or you don't have some outlier. You can still use this report, but if you had no acreages, you would have the number of acres figures would be blank, and you would just see the number of component. The figures would only be populated for the number of components. Okay. So there's just a couple other things that I want to mention. There are a few fields in this report that are not as simple as reporting as others. Things like elevation come directly out of component data, and they're really simple. But some of this data is a little bit more difficult, like let's look at surface fragments. So surface fragments are a little bit more complicated because the data in NASAS is not really designed to be able to give us surface fragments between surface fragments less than 3 inches and surface fragments greater than 3 inches. Particularly, the problem becomes when you're working with component low and high data, and there are multiple fields that need to be added together. For instance, if you had surface fragments with different shapes, and you need to add those together to determine the total amount of surface frags, when you start adding high values can range kind of in an independent way. And what makes this subsurface frags is an even more clearer example of how this works. Subsurface frags are reported for each horizon, and then you basically use a weighted average for each horizon to determine the subsurface frag volume for the for the soil in general. But what can happen is that fragments, let's take, for example, fragments greater than 3 inches. Well, those would be stones, cobbles, and boulders. And each of those can vary independently. Cobbles could range from 30 to 70%, and boulders could range from 30 to 70%, and maybe stones, I forget what the third one is that I haven't said, could vary from 30 to 70%. And those values might be a little bit high. But the point being is that when cobbles are really high, it's likely that stones and boulders are lower. And so it's not as simple as just adding up the high values. If you were to add up just the high values for all of those, and you did 70 plus 70 plus 70, you could get up to over 200. And we know it's not possible to have 200% volume of rock frags greater than 3 inches. So this particularly subsurface frags is something that it's not an exact calculation, and there's discussion about this in the report. Lots of sections have discussion, and it is worth reading this discussion to make sure that you understand how this is working. And particularly for subsurface frags, it's good to remember that this should give you a reasonable range of values, but it's not an exact calculation. And it's something worth discussing with a soil scientist, what values you're seeing to make sure it makes sense to what they're seeing. Particularly, the report relies on total fragment volumes, which is populated for each horizon, if that field is populated. For older surveys, it's not always populated, and that's one less constraint that's on this report to help make sure it's in the right range. And when it's working on some of those raw values without more constraints, it has the tendency to, or the possibility to really have more issues. So look at subsurface frags with some scrutiny. Another thing that I'll mention is that the subsurface frags will be reported. Sorry, let me just see. Okay, this subsurface frag section will basically tell you the depth range that it's reporting for. And it basically goes, it will say here, use the following value as the top depth. This value is the median of the acreage weighted RV component depth of O horizons. So it is also telling you here, so if we go to surface fragments, subsurface fragments, excuse me, these are standard properties by depth. Okay, so there's a depth range associated with this. In the past, I had often been using 0 to 60 just as a default depth range, but this is not always the case. Some of these soils don't even go to 60. And so this report will actually tell you what values to use. Sorry, we seem to have jumped, or maybe it was, okay. The report is telling you what values to use for your top depth. Top depth is 0, and then it says use the following value as the bottom depth. And so the bottom depth is 17. So it's telling you that from 0 to 17 is what it's reporting subsurface frags for. So it will tell you 0 to 17 is your range for subsurface frags, and then it will go on to give you your actual highs and your actual lows, and so on and so forth. So please do look at some of these different sections. Surface frags is another section. It's surface fragments. Surface frag. Okay. Surface frag is another section where there's not an exact calculation when there are fragments, as I mentioned previously, fragments of different sizes, and you start adding things together. There's a possibility that you could go over 100. When you're just adding up high values, it has the possibility to go too high. And when you're adding low values, it has the possibility of going too low, because it's unlikely that everything's at its lowest value at the same time, and it's unlikely that everything's at its highest value at the same time. So look at surface frags with some scrutiny as well. And if there's someone, if you're familiar with these soils or ecological sites, or if someone else in your office is, it's worth kind of looking at those values and knowing that these are not exact calculations. So yeah, that should cover a lot of that. For those of you, if you are interested in digging into some of these things in greater detail, you can go to this report. We haven't gone over this report in this video, but in the other video about about producing these reports, I go through this process. And so just to make you aware in this video, these reports are basically visual representations of a NASAS report. And that NASAS report is stored in the MLRA 02 Davis folder. If you go down to export ecological site concept data by MU key list version 4, you can go to that and you can go to the report, and you can, if you're interested in looking through how exactly this works, looking at the CBIR, you can do that. And if, subsurface, if you want to know all the details of how subsurface fragments are calculated, you can go and see the interps that are used for these different sections. So yeah, just as a reminder, the report does give some kind of warnings for different sections. Where there are sections that there's not an exact just calculation or just pulling in values like elevation and things that are simple, for things that are more calculated, it'll say things like this: make sure to read the soil depth section description above. Soil depth calculations differ from other sections. So where there's more complexity, it does make you aware of that. So I won't get into all the little kind of minute details for these more problematic sections, but I want you to be aware of reporting things by components and acres, and how these standardized values. That's kind of the biggest thing that I want to be clear is calculations for standardized values. So I hope that that's clear. And if you have any questions, you're more than welcome to reach out to me, and I'll try to do my best to answer them. Okay, thank you.